Hey guys, welcome to my stream. So last Wednesday, I was working on this whole thing about getting like the lines to kind of like collect all the lines that we need to draw rather than draw them directly into a buffer and darken them. Trying to do it on the CPU side, and I got stuck for a little bit last week. I had this problem, which you'll see right here. Let's just do this, where it was like flickering like crazy. Anyway, so basically after the stream and after thinking a little bit about it, sleeping, taking a shower, and thinking, I realized what the problem was. And in fact, I wrote a whole bunch of debug code just to see if I was right and what was going on. But basically what it boils down to is that this optimization that I wrote last week, where I have this huge buffer of lines, right? And in order to not kill my frame rate by constantly deleting in the middle of this big collection, or actually most removals would happen at the beginning of this collection. I tried to be clever and implemented this iter swap idea, where we swap with we put an iterator at the end and one past, like we initialize our end iterator at one past the last valid element, so at the end, and then every time we need to remove or delete something, rather than delete it, we swap it with the end iterator but brought back to the previous element, which would be a valid one. And so we swap. And the idea there is that this is actually a really good technique for very quickly doing a bunch of removals in the middle of a vector by swapping them with values that are valid at the end. And then this end iter is used to erase the set of invalid values, but in one chunk at the very end. And that kind of erase actually doesn't cause any moves or any reallocations or anything to occur. It just basically ends up, since all this chunk at the end are all invalid, this erase will end up simply setting the size of the vector to be smaller. So it's a really optimal way to do it. However, it only works if the order of your elements don't matter. And I erroneously thought it wouldn't matter, but of course it does matter, because what the vector ends up looking like really is like, let's say on frame n, we end up drawing, like, say, vector A, vector B, vector C, vector D, and vector E. These are different vectors, right? Well, at frame n+1, we'll end up actually very highly likely redrawing the same vectors, Maybe we won't draw A anymore, but we'll draw B, C, D, E, and then perhaps F, and then that's, similarly, n+2, maybe we'll draw exactly the same ones, but then n+3, maybe we'll remove B and draw a G here. Now, the thing is that when we drew, let's say these three B's here, when we drew these, the first time we draw it, each one has a brightness value, and the brightness value becomes darker and darker. That's part of what I do is I have this darken. That's what this function is doing. It's darkening lines, right? It's taking each one and it's reducing its brightness. Now, let's say this B ends up becoming invalid and I swap it with some element at the end, right? Like some valid element at the end. G over here. And then I swap, let's say, C with this F. Well, now right there you can see the problem is I've moved an F that has a higher brightness value earlier into the list. And then we draw these in order from left to right, and so we end up drawing vectors that have a higher brightness first, and then overdrawing with a vector that has a lower brightness afterwards, and then that ends up looking like this. You can see like it's basically, you know what, I'm just going to remove it's getting in the way. I'm just going to remove some printfs here. And this one here. Yeah, all of this was my debugging code. Okay. Okay, there we go. So this crazy flickering that you see going on here, and if I pause, the pause really shows the problem. You see, like it's crazy, right? Like it's what's going on in here. And this was what was frustrating me last week because I didn't understand. But in the end, the problem was exactly what I just explained. And when I realized that, I decided to go for a different solution just to see if I could fix it. And so the different solution, just undo this here. Okay, so if I just comment all this out. So the way I fixed it is like this. So I mean, this is a bit of a hack there, but I have, let's say, a static all lines 2 here. This would actually just normally be a global, and the idea is to do double buffering, right? Yeah, this totally should be a global like the other one. But anyway, the point is that in this case, what I do is I start with this all lines 2. It's a static, so it's going to be allocated once and reused over and over. I make sure to clear it, which won't matter the first time, but it will matter on the subsequent times. And then, as we go through, every time we decide it's time to keep a line, I add that line to this all lines 2. So I clear it, and then I keep pushing back onto it every valid line I want to keep in order. And then at the end, G all lines 2 is contains all the ones we want to keep, whereas lines contains all the lines, partially including those we don't want and those we do. And finally, I swap the contents of lines with G all lines 2. And so when we leave this function, lines will contain only the lines we want to keep. This is actually quite efficient because once this G all lines 2 grows to its full size that we want, just like G all lines itself, like basically these two buffers here, there'll be this one here and then this local one here. They'll both grow to this one size that will fit all lines or the maximum number of lines we need to draw. And after that, we're basically just moving lines we want to keep, which is fairly fast operation, and then swapping the two buffers internally, which is really fast as well. And so then that gives us a solution that actually works, finally. So let's take a look at that. So if I just remove the overlay so we can see it better. See, now this looks as good as it used to, right? And so here, and I can play with the darken, speed, alpha, you see. So it works just like it was working when we were doing the darkening in the pixel shader. So everything works again. Now the only thing is, if we pay attention to the frame rate, okay? So let's say I put this back to my default of 3. See, my frame rate is averaging something around. Okay, well now actually you see there's a huge dip in the frame rate when the big ship comes down. And then when I'm like normally playing, I think it's around 170 or something, like 175 usually. See, right now it's around 166. But let's say it's around 160. So it's about 160 when I'm playing. Then if I die, it's gonna drop down to like 96, 78, 92. What am I trying to say here? The point is that because we've moved the management of all lines to the CPU, we are now completely at the mercy of what's going on in the CPU, and in particular, the frame rate will be relative to or proportional to how many lines we have inside this buffer. So like when the big ship comes down, there's a whole bunch of lines that are being drawn more than when we usually are in gameplay, and that's why the frame rate drops. Also, overall, the frame rate is lower now than when I was using shaders, because using the pixel shader to do the darkening, because we're doing all the processing on all this processing is now serial and it's on the CPU. And I could make it parallel. I mean, this is actually a pretty good algorithm for parallelizing for the most part, except for the ordering part, which kind of sucks. But maybe we could chunk it and all that. But still, that would just be taking advantage of how many cores you have. Ultimately, what we're doing, before the solution was we were only taking the lines that we had to draw this frame, drawing them into a buffer, and then letting the pixel shader darken all the pixels, and effectively that's like as parallel as it gets, right? I mean, you have to use the GPU for it, but most people have GPUs today, and so that's a pretty good solution. So it would seem kind of like maybe like a no-brainer. We should just go back to the old way I had things. But actually, I've been agonizing over this decision because the one thing I like about this solution, and I mentioned this last stream, and it's what I keep thinking about, is like in general, for the Vectrex emulator core, if we forget about rendering, it kind of makes sense that the emulator manages the lines for the display, manages which ones would get drawn, manages the brightness for them, and kind of makes it easy for the rendering to just say, hey, just take these lines and draw them, right? Like at this brightness. Whereas going with the original solution I have, where we let the pixel shader do the darkening, we put the complexity on the side of the rendering. The contract with that scheme is, we won't give you all the lines you have to draw this frame. We'll just give you the delta lines from this delta frame, just the new lines that have to be drawn this frame. But any old lines I've given you, I won't give them back to you. I won't tell you anything about them. It's up to you, renderer, to manage those lines, make sure that they're getting displayed and darkened over time. So that's the original contract that I had with my code base, which makes it a bit more complicated for the rendering side. But I agonized over it, I thought about it, and I decided that I'm gonna go back to using the pixel shader because it's faster, because I don't think that it's that bad, asking the renderer to do that kind of thing. And finally, I like that this way is agnostic to the number of lines being displayed. Oh, hey, Steven. Thanks for joining. So yeah, so all that to say is this works, but I'm just gonna set this aside and I'm gonna go back. So I have here, this is the beauty of working with Git, is that you can make as many branches as you like to mess around with this kind of stuff. And there are some things in here that I might come back to. Maybe I'll go back to this solution in the future. We'll see. But for now, I'd like to go back to what we had here. So this here just goes back to where we had implemented the Gaussian blur. Let's just get that up and running. All right, so yeah, here we go. Let me just take off the overlay for a second. Yeah, so this is like some massive serious blur going on here, right? So if I just reduce the blur, so this is no blur at all, and then this is with some blur. So yeah, so that's what we have. We had like a couple streams ago, or at least before last stream. So my plan now is to go here, and I'm gonna try the different angle. I'm gonna go with the angle now where we'll take the batch of lines we need to draw this frame. I'm gonna try to do the thicken of the lines. So I'll take the code I wrote last week that converts the lines into quads. So we'll make them a little bit thicker, and that will be our line buffer. We'll draw that into a texture. We'll blur it into another texture, and then we'll take the two and we'll combine the blurred version and the unblurred on top of it, and we'll see how that works out. So that's going to be my focus this stream. So let's see where that takes us. So let me see here. There was something good in what I had done here, so let me see if I can steal that. Go like this. Line. Yeah, I might need to do this again, the texture too, the second glow texture. I think I will need that. But the part I wanted to take was, where's that code I wrote? Here. Create line vertex array, where I take the lines yeah, this is it. So I'll just grab this code here. So this was the code I wrote last stream, where we turn our lines into quads, which is really good. So it'll make it thicker. So we'll start with that. I don't remember where I had it, but let's do this. Yeah, and when I did this, I did not need to worry about this here. Oh yes, the vertex data, so I'm going to do that as well. Yeah, I'm just going to steal a bit of code back from what I had written before. And I had it returning, yes, result. I think it was here. Vertex data was stored oh yes. Basically, I just need a vertex array for everything. This became GL triangles. We'll be drawing triangles, so we'll be drawing 2 triangles per line. Okay, so I have this brightness thing that I have to bring back. In fact, I was thinking about this brightness thing and how I might actually change that to be either change it or add a color value at some point. But anyway, we'll get to that. I don't need to talk about that now. HLW, what was that again? Oh yes. That's right here. Alright, defaults to 1, okay, so that's okay. Alright, so I've got the brightness settings here. Alright, so basically we go through the lines, we create some vec2s, we check if it needs to be a dot, and if it is, we just create a square. Is that what I did here? Yeah. Hey Steven. Steven asks, how many emulators have you made over the years? This is my second. The first emulator I wrote was a NES emulator, which I wrote a couple of years ago now. That was the very first time, and I learned a ton by doing it. I didn't really study hardware, so it was a really great chance to kind of like learn more about hardware. So that was pretty fun. But this is my second. This has definitely been easier for me to write because of my first experience with the NES emulator in one way, because like I had some experience, I knew how to write an emulator, but also more difficult in another because there was a lot less documentation for the Vectrex. So yeah, I had to figure out some stuff and try some stuff on my own. And for that I actually wrote more sophisticated debugging tools to help me figure that stuff out. So it's been a really interesting experience. And what I like too is it's pushing me because it's vector graphics. Like for the NES emulator, I just did it's just 2D, right? So I just used SDL and did just good old, you know, what is it, SDL surfaces and just basically bit blitzing, setting color pixels for each pixel and all that. For this one, I decided to use shaders and OpenGL, so it's more interesting because it's vector graphics. I can play around with it a bit more. So that's cool too, because I'm not really a graphics guy either, so this has forced me to learn more about graphics. And that's why I do these projects, right? To learn. Okay, so I've got this here, and I gotta return it. So this allows me to create the line vertex array. Now, the next stage was I'm just gonna steal my changes right here to these guys here. So I'm gonna cherry pick these, cherry pick, and cherry pick. So I got the changes to my fragment shaders here, so that the vertex brightness is taken into account. And let me just grab the changes. Let's see. Yes, I might need this. So this is like two changes mixed into one, so I don't want all the stuff for the CPU on the lines on the CPU, but I do want the part where I'm creating the lines as actually, is there anything else I need to do except for maybe binding the brightness? I think that's all I had to do. Yeah, I don't want to clear. Okay, here we go. Yeah, that's it. This is what I need. Vertices and brightness value. So this is for pass 1. Don't need to change that. All right. Okay, so now I'm passing in vertices and brightness value to my shaders. This is where I was actually creating. Right. All lines. So, right, this is not going to work anymore. So here I'm pushing line BA here. Right, now for draw lines, I just need to push back the lines and then convert later. I guess I could convert here when I draw. I might just keep this simpler. Is this correct? So yeah, so now I've got, this guy's got filled up with the vertex data that I need to draw this frame. And here I'm drawing it as triangles. This might be it. I think there's not much more I have to do here. Let's see. Let's just see if that works, or see if it builds even. Okay, and glow radius. Yeah, this looks like it's working. I think we play with the line width. It's like funny because we can get to like a line width where it doesn't draw anything at all. I wonder if I should have like some kind of minimum that would make it so that it always draws. Like, why does it? Yeah, so like 0.5 means that there's a thickness of 1, technically speaking. But you see, it's actually thicker than when I didn't have this kind of normal line drawing. But I mean, I think it's fine. I think this is pretty good, actually. And I think if we blur this and then redraw that on top, it may actually look okay. I'm not even sure we'll see it. But we'll try. Because like another thought I had is, you know, draw like really thick into another buffer and then blur that. And then draw the thinner lines on top, you know, maybe. So we can play around with this, but of course, separating the thickness that I need to draw, like not having the same thickness, means that I'll need more buffers, more, like way more screen space stuff that's going to be going on here. Let me think about this for a second. Like right now, do this. That's a darken pass, and then I have a glow pass right now. Probably what I'm going to want to do then is do like I'm gonna have to draw twice. Draw once at the thin level and darken. Draw again a thicker level, darken it, so I can swap these two later. Then this one here is gonna get blurred horizontally, horizontal blur, and vertical blur. So I've got 1, 2, 3, 4 buffers there, 2 buffers here. I have the CRT texture. So before I do that, I need to do the blend that I want to do. So I need to take, yeah, I guess in fact, let's call this A and B, C, D, E, and F. And the next one would be to take A and F take A and F, so take the final result of the blur, and then A, choose what's on F always, and then add A on top if it's non-black. So this will be like the non-blur over blur, and we output it back to E. And then we can take E as input to the CRT texture. So this will be like combine screen. What do I call this thing? Yeah, game screen plus blur. Then it's game screen to CRT texture. And then finally the render to screen. Then it's like CRT plus overlay to screen. A bit more notes here. Okay, so this will be like kind of scratch 1, scratch 2. This will be Okay. So actually, I won't do it this way. I will actually store the lines that are coming in here. So this should give us the same thing. I'm gonna actually commit this now, since it's actually working. The only thing is, it bothers me that I have this way of drawing these lines, but it must always be a rect, and I can't do the actual GL lines thing. I'm noticing something a bit strange in yeah, I think I need to make my dots thicker for them to be visible. So maybe what I'm gonna do is I will actually draw lines for lines and draw quads for when it has to be quads. Yeah, I can totally support that. Create, how can I say this? Let's say create quad vertex array would be for when we want to do this way with triangles. But if we wanted to draw it instead as just points, then I come back to needing two separate ones, one for GL lines and one for GL points. Maybe something like this. Let's see if this works. Okay, so this should bring us back to what we used to have before, which it looks like it is. Like the thickness here, don't even see it because there is none to change. Yes, this is back to the classic lines that we had, which is kind of good because I want to be able to draw these lines and dots on top of the blurred version. In fact, if we draw this like this, now no matter how thick or thin, I should always see the points because we'll be drawing them twice. Yeah. See, now even if I set my line width really small, the normal line drawing kicks in and takes care of the fact that some were disappearing. Yeah, see, that's cool. All right, that's good. $576. Okay, line looks like this. I've got these. So I'll put here support for how did I do the brightness thing again? Did I need the brightness? Hold on. Actually, I didn't. I don't need the brightness on the outside, do I? But I'll keep it because I will need it eventually. Yeah, that's right. That's right. That's right. Yes, yes. That's going to be like the initial brightness for that line. Yeah, okay. Lines with add initial brightness for lines and for drawing thicker lines. Okay, now you know, one thing I did last stream was, for one of these I had put it into a little function, and I kind of liked how I had passed in the input and output textures for the passes and stuff, and it started making me think about how it might be nice to start, like, yeah, putting these into functions. Maybe make it more clear, especially now that I'm going to be messing around a lot with which buffers I use for each one. Let me see if I can simplify this. I'm going to rename this to draw vectors. Makes more sense. And there's also another thing I want to do, which is all of this crap here. Grabbing the texture ID just to set it afterwards. I'm gonna wrap that up. Set uniform. shader, the uniform name, and then the value. So that's it. I don't really have many overloads to write here. This would be 1f. 2f would be 2 floats. Okay, so this should clean up the code a little bit. Let's see how this works out. So I'd be able to say this shader here, rendered texture, and the value will be 0. So that would be this bit here. Frame time ID, similar. It's going to be a float in this case. Darken speed scale. Which actually was setting before the time, so I'll do this. And that basically gets rid of this here. So I don't need to do the get and then the set everywhere. What's good is if I want, I can put some error checking here, see if the get uniform gave a valid ID, or see if this actually returned something expected. So we bind there. See, anything that makes these bits of code shorter will make it easier for me to factor it out. In fact, one thing I can do here, cur shader, because this is going to become an input parameter, making it easier for me to factor this out. So now everywhere I see this here, I'll put cur shader instead. For glow, I'll do the same thing. Not in here. In here, I suppose. Okay. In fact, I'm just going to call this shader. Becomes radius. This is kernel values along with the size. This I'm actually going to get rid of. We're not going to play with these anymore. And then finally for the direction, it's these two guys here. Make sure this works. Looks like it's working. It looks like it's blurring as before. Okay. All right, let's keep going. Yeah, I didn't do the... I don't know why I'm keeping this. I don't think I'm going to be using this anyway, but okay. So here the shader is this. Well, actually I don't have anything here. Huh, interesting. I even had the wrong thing for darken texture. See, this is exactly why you need to do this kind of thing. Copy paste bugs. How did this work? Game screen to CRT texture. Not sure. Guess we were just lucky. Okay, render the screen. This is draw screen. See, I actually wrote this function set texture uniform. Okay, so this one's a bit different. Did I really need to do this? Activate the texture? I don't think so. Oh no, I did. Yeah, it might be useful actually, since I keep doing this for binding textures. So we'll call it texture slot or something. Okay, we'll make a template to generate this code. And then we'll have a little mapping. And we'll say constexpr. This is where constexpr is fun to use. Texture enum or something. So this gets us the enum, and then we can bind oh yeah, and we should pass in our texture resource name and then the texture ID. So let's see if this actually compiles. CRT texture and star CRT texture. Okay, so something is not good. Oh yeah, we're supposed to say 0. Right, not all control paths return a value, that makes sense. Like, I wonder if I can do something like this. Can I put... I don't think you can do static asserts or something like that. Like, you can't really catch the invalid case, right? That doesn't work. No. Also, is it because I need... Yeah, static assertion failed. There's no way, I guess, yet to do this part, which sucks. I guess what I could do is I can make it instantiate an invalid template. Like if I just do like template or like not implemented or something. Cool. So this means that if I was to pass something invalid, like, so 0, 1, 2, 3 should all work. Like if I go to 3, if I pass 4, I should get basically that it's not implemented. That wait. Does this work? That exertion failed, but if I put 3, does it pass? No. I guess because it becomes a linker error, maybe. It's not really a type. Well, let's see, even if I get a linker error, it's better than nothing. So not implemented, even though I'm passing in 3. What do people do when they want to have, like, const expert function? Addressing this in C++14 is trivial. The language guarantees that if the expression inside the assertion evaluates to true at compile time, the assertion is a constant sub-expression and does not impede the compilation evaluation of your function. How so? Like, which assert are we talking about here? Oh, I see what he's saying. So why doesn't this work? He's saying that basically a const_expr function needs to be a constant expression. I guess because I'm not guaranteeing that this must be done at compile time. That's one thing about const_expr is that it can generate code for runtime. This may be also Visual Studio not working for me. Oh yeah, this is not supported by all compilers. What a mess. Okay, whatever. I'll leave the assert in there so that it will fail at runtime if we ever do the wrong thing. In fact, I won't do this. I'll just do assert false and put that in the okay. Let's see if this works. In fact, we'll try to see when we put the invalid value if it actually asserts. This was the CRT texture, so it looks like it's working because we wouldn't see this guy. And we don't get anything, and it still seems to work. CRT texture. How is this working? Shaders are weird. It's like using like whatever was last bound to the texture slot 0. I think that's why it works. Like it sort of works, you know? It's not, this time it didn't do the right thing. It didn't scale it properly. Curious what this looks like. I think I might have to go into debug. Oh, that's interesting. Compiling this in debug did something, because I guess this didn't get discarded. Yeah, so you're saying failure caused by usage of undefined function because of the assert. Interesting. Would this change if I put a valid value? It does change. Okay, so now I'm thinking if I pass this in here, and it still passes release. So somehow, when we build in debug, it actually gives us an error where release would not. That's like some strange const expert stuff going on with MSVC, I'm gonna have to guess. That just makes no sense at all. But anyway, if at least it's caught in debug, I'll take it. Alright, so then technically I should be able to do the same here. Shader, overlay texture, and texture ID will be star overlay texture. And then here we say set uniform shader overlay alpha and we pass here alpha. Oh, I'm not getting my overlay, so I must have made a mistake. Interesting. Oh yes, GL texture location, I need to set this value to texture slot. In fact, yeah, that's fine. Okay, there's our overlay. Looks good. So actually now this code gets nicely reduced. To this. To this? Yeah. So much easier to read when your shaders take less than a screen, or at least your shader passes, I mean. Yeah, these are just some helpers. Pretty happy with that. What I'm gonna have to do is make some kind of shader helper, shader util or something, because I have so many things here that are just useful for that. Okay, let's keep going. Maybe not lines, maybe vectors. Okay, so those will be the thick ones, glow texture, CRT, and overlay. Glow, I'm going to need 2 of them, but I'm going to call this okay, I'll keep it like this for now. Alright, so we've got our textures. My only problem right now is that I want to put this into a little local function, except that there's two ways to use it. I either draw triangles or I gotta draw points and lines twice. Like, I mean, either draw one buffer or two buffers. Oh yeah, what am I doing? see if this even works. No, it's not enum one, it's mode one. Broken. All right. That makes sense. I need to actually do this. Okay, and now let's move this out. Right, so what we'll do is we're going to give an explicit parameter type instead of auto, and we should be able to do this. There we go. So let's see if that works. Now we should be able to see thicker lines. Yeah, that's working. I want to try and make them thicker and see what that looks like. Cool. All right. So, I mean, it's not amazing, but I'll take it. Basically, what I did is I turned this function into one that can take up to 2 arrays, and I try to draw both. And in here, I just check if one of the arrays' size is 0, we just don't do anything, which is what happens in the case of drawing the thick lines. I only need to draw triangles here and nothing for the second bit. So that's fine. I mean, it's not beautiful or anything, but it'll do. So now one thing I want to do here is I want to be able to pass in the 2 textures that I want to use. Oh yeah, and I wanted to rename these. Okay, I'll do that after. So that's the input one, and we set the output one somewhere. Oh no, sorry, that's in the next pass when we darken it. So in this one, we just need to give it the target texture, and then that's it. fact, let's try drawing both, like we did last time. Blurred and normal lines. Actually, before I do this, oh, that's fine. So I'll put here input texture, GLUint, output texture, ID. I always put ID, and then we'll say, because here we're going to want to play with the other ones here, so we'll say this is the output texture ID. And this will be the input texture ID. I'm turning all of these into local functions so that I can reuse them when I'm going to do my thicker lines for the glow. Technically don't need to do this one, but I'll do it anyway. Because what I like is being able to identify the textures that are in and out. Temp texture, and I'll say output texture ID. Basically, apply glow needs an extra temporary texture to do its work. This is where we're headed. Alright, draw full screen quad. Yeah, I'm gonna have to capture this unfortunately because this is... No, I can't do this. Why can't I use this? Because of that? Yeah, okay. Okay, so that works. It's so funky. I have like a lambda that calls a lambda. This is a bit redundant, but still, I'm gonna do it because you'll see why. This is not right. This is, yeah, this is right. Input and input. And here the output is actually the screen, so we don't have to say it. All right, great. So now I can actually take off these extra scopes here, unnecessary now, since these are all in functions. In fact, I want them in the parent scope so that I can move the calls to the bottom. Like that. Mainly wrapping shader code into local functions, looking input, output textures. Alright, and this is what I wanted to do was, let's do this, let's split. Move this down. Okay, so we got draw vectors, darken texture, apply glow, game screen to CRT, and render to screen. So now we actually see the flow of everything I'm doing. So let's see if this works. Yeah, it still works. It's good. I have to say, I really like this look here. It's just like bumping up the one kernel value up here. And it gives like a cool glow, you know? Just don't like the trail that it leaves. That's the only problem. Okay. So now that I have that, actually these pass numbers are starting to have less meaning. Or at least at this point they do. But anyways, because I'm going to be bumping these numbers soon. Draw vectors, darken shader, apply glow, game screen to CRT, render to screen. Okay, so let's see now what happens. So what we want to do is, this is the finally where we have a bit of fun with this. I'm wondering if I should just commit this like this first. Gather all render passes together. All right. So let's see here. You know what? Frankly, I don't really need this cur render texture stuff anymore since it's just being done. Okay, I'm gonna delete this here. What did I call it again? That thick line one. So first we render normal lines and dots and points and darken. Now render thicker lines for blurring and darken. Then we apply the glow to the thicker one. Using glow texture 0 and then output to glow texture 1. So now glow texture 1 has this. Now I want to take that and I want to do the combine. Combine glow and normal lines. So this is where I need to actually write a shader for this one. So for that, yeah, I'm gonna have to do that. Okay, so before I do that, just put a to-do here. I just want to see if I were to if I draw it this way, we should at least see the timing, and we should be seeing the thicker version and the glow applied only to the thicker version. Yeah, that seems to be working. Let's see. Maybe not. The line thickness is not doing anything. Let me see here. Curve vector is thick texture 0. Then we darken from there to there. Apply glow using the curve thick texture 0 to the glow texture 0. And do the final pass into curve vectors texture 0, which should overwrite what was done up here. So why aren't we seeing this? Basically, this should be a no-op. Hey, Sad Dog 69, how's it going, man? Aha. Hey Alvaro, thanks for joining. Sad Dog asks, what am I working on right now? I am working on, basically, I'm rewriting my rendering code so that I can render the Vectrex lines in a thicker way and apply a Gaussian blur to them to get like a glow effect. And then the idea is to then, on top of that, draw the normal lines so that we get the normal lines with a glow effect around it. And right now I'm just testing to see if the part where I draw the thick lines with glow is actually working, which it doesn't seem to be. Sad Dog asks, to make it look better? Yeah, exactly. To make it look better. I'm trying to go for like, I don't have a great picture there, but where is it? I had a picture somewhere. Oh yeah, something like this, you know, like where you can kind of see the, okay. Kind of like a glow effect like this, you know. That's how I came up with the idea to add the glow. I mean, I don't even know if it's going to work, right? But that's what all of this is about. Just kind of try things. Sad Dog asks, because that's what the original looks like? Yeah, exactly. This is what the original looks like. There's always this kind of a glow effect, you know? You can see it on all these images. Because basically it's a vector display, and you know, the beam just basically moves across and excites the phosphors, and because it's a CRT screen, there was this natural kind of phosphor bleeding that would occur, and then the longer the beam would stay, the more it would glow. So, you know, I probably won't get the exact same look, but I want something that kind of looks like this, you know, and something that we can play around with. Sad Dog says, have I worked with vector-based graphics before? No, not really. I mean, I'm not sure what you mean by that. Like, I've done OpenGL and lines like that, you know. But if you mean like on a actual hardware vector display, no. The latter, so like hardware, no, I haven't. I'm not actually really a hardware guy. I'm definitely a software guy, just interested in hardware. And these kind of projects help me learn about it. Sad Dog says, that sounds like it'd be a challenge. It'd be challenging to learn. Yeah, I guess so. I mean, so this is my second emulator. I talked about this earlier. I wrote a NES emulator, so that was really my first time kind of digging into hardware. I'm like learning more about like, you know, stuff like how interrupts work, about latches, shift registers, things like that. And a lot of those things have helped me to understand how the Vectrex works and implement this emulator. But the stuff I didn't do when I did the NES emulator was this kind of stuff, the vector display. So it's been kind of a fun challenge to learn more about that. And yeah, it's been really cool actually. Just gonna open up RenderDoc. Sad Dog asks, what language was it written in? You mean my emulator? It's C++. And I guess I'd say C++ 17 because I'm basically using a lot of the newer features that have been added to C++ 17. Okay, I'm kind of racing against the clock here because I should be stopping soon. Just want to see what RenderDoc shows because I might be missing something. CRT texture. So there's definitely a mistake here. Back buffer, overlay texture, CRT texture. Input texture CRT to glow. That doesn't look right. Sad Dog says, I was just stopping by to get some ideas for what coding to get into. Good luck on your project, dude. Thanks, man. Thanks for stopping by. And good luck with coming up with something for your project. I can definitely recommend writing emulators. They're really fun. You learn a ton. What is going on here? Why is this? This draw, this doesn't make sense, this draw right here. It says that rendered texture is CRT. Input here, input textures GCRT, and then FBO is bound to glow texture 0. And then here we have glow going to curt text. So this one here corresponds to, this is the apply glow pass here. It's as though this guy here being set to the wrong thing. Input CRT goes to glow, texture 0, and then glow texture 0 goes to curve vector textures 0. And this is the final pass. So this is the glow. I don't understand how this becomes the input to the glow, FS0. And now I have the darken up here apparently, which is also not working. Where's my draw vectors? It's supposedly this one. Wait. I think I know what's happening. Okay, yeah. Probably need to clear it at least once, but that's not really it, is it? Surely not. Wait. Oh, I never allocated the thick textures. Well, that'll help. Yeah, there we go. So this is the thick version, and then on top of this we'll end up drawing the thin version. Oh, and at least we'll be combining the one we draw. So you know what? This is a good place for me to stop. Yeah. I'm going to stop here, and I'll be resuming in just a couple nights. So if you want to see where this goes, Wednesday night, usual time. So yeah, guys, thanks for hanging out, and hope to see you in a couple days. Take care.